Good day, my viewer. My name is Olagunju Joshua, a chemical analyst working with Federal Institute of Industrial Research, Lagos, Nigeria. In this video, I would love to teach you how to prepare standard sodium hydroxide solution. Sodium carbonate solution. Rather, sodium carbonate solution is a solution that can be used to standardize other chemical reagents in the laboratory and industry. So without wasting time, by this time around, I'll be taking 0.1 molar sodium hydroxide solution, sodium carbonate solution. We'll be preparing 0.1 molar sodium carbonate solution. First of all, when we talk about standard solution, don't forget I said sodium carbonate standard solution. When we talk about standard solution, what do we mean? Standard solution means solution of known concentration. Solution that its concentration has been determined. That's the meaning of standard solution. So we'll be taking 0.1 molar as the concentration of the sodium carbonate that we prepared. So we're going to the preparation of 0.1 molar sodium carbonate solution. So in order to prepare this sodium carbonate solution, 0.1 molar sodium carbonate solution, some apparatus will be needed. Among the apparatus that will be needed, number one is our standard flask. 1 liter standard flask. 1 liter or 1 ml standard flask. Another one is our wash bottle. These are our distilled water. These are our funnel. Our beakers, spatula, petri dish. These are our salt, our sodium carbonate salts. While our oven is over there. Oven and our desiccator. So first of all, how do you know? We need to weigh a certain amount of the salt, of the sodium carbonate salt into the beaker. We dissolve it in the beaker and then transfer into our standard flask. Now, how do you know the amount? How do you know the amount of the sodium carbonate salt to be weighed and poured and transferred and dissolved in 1 liter distilled water? First of all, you need to know the amount. You need to know the amount of the salt. Amount of the salt needed to prepare 1 molar. After getting the amount of the salt needed to prepare 1 molar, you now divide it by 10. Divide the amount by 10. Now, we'll be able to get the amount needed. We'll be able to get the amount needed to prepare 1 molar from this formula. Let's look at the formula. The formula is molarity. Molarity, which is M, that stands for molar. Molarity is equal to mass over molar mass. Over molar mass. Mass over molar mass. That means for us to get 1 molar sodium carbonate, the amount of mass, the weight of the sodium carbonate that must be weighed must be equivalent to molar mass of the salt. Must be equivalent to the molar mass of the salt. Now, let's calculate the molar mass of the salt. What is the molar mass of the sodium carbonate? Let's calculate it. The chemical formula of sodium carbonate is Na2CO3. The atomic mass of sodium is 23. That of carbon is 12. That of oxygen is 16. So let's continue with the calculation of our molar mass. So that is 23 times 2 plus 12 plus oxygen times 16 times 3. 23 times 2, that is 46, plus 12 plus 16 times 3, that's 48. So summation of all this will give us 106 grams per kilo. dm cube is also equivalent to 1 liter. Once say dm cube, we are also referring to 1 liter. Now, that means for us to get 1 molar sodium carbonate, 1 molar concentration of sodium carbonate, 106 gram of the sodium carbonate must be weighed and dissolved in 1 liter. But this time around, we are not asked to prepare 1 molar. We are asked to prepare 0.1 molar. In this video, we are preparing 0.1 molar. Now you get the amount of the amount of salt to be weighed and dissolved in 1 liter volumetric flask to give us 0.1 molar. How do you get that? Is 0.1 molar. That's what we are going to divide. We are going to divide by 10. When you divide 106 by 10, it will give us 0.6 gram. This tells us that 10.6 gram of sodium carbonate will be weighed. 10.6 gram of sodium carbonate will be weighed and dissolved in 1 liter standard flask to give us 0.1 molar. Now we are going to weigh 10.6 gram of sodium carbonate in a 1 dm cube. Mind you, don't forget I said 1 dm cube is also referring to 1 liter. 1 liter, so referring to 1 liter or 1000 cm cube. So you can either use, when I say 1 dm cube, you are also referring to 1000 cm or 1 liter. So let's now continue with our preparation. So we are going to weigh 10 grams of sodium carbonate and dissolve it in 1 liter volumetric flask. Let's continue. By this junction, we are going to take some quantity of the sodium carbonate salt. Take some quantity of sodium carbonate salt and put it in an oven. Some quantity of sodium carbonate salt. We are going to put it in the oven that is set at 105 degrees C. 105 degrees C. Wow, put it in an oven. We are putting it in the oven in order to dry it very well, to remove any moisture in the salt, so as it can give us an accurate result. So now I'll take it into the oven, put it in the oven to stay for 2 hours. So after 2 hours, we'll come and remove it and put it in a desiccator. Now we have removed it from the oven and from the desiccator. Remove from the oven. Don't forget I told you that after removing from the oven, you cool it in the desiccator. So we are removing from the desiccator now after cooling. The next stage is to go ahead with weighing. We are weighing 10.6 gram. Now this 10.6 gram sodium carbonate has some quantity of water into it to dissolve it before transferring it into the volumetric flask. We are going to dissolve it first in the conical flask. This is my volumetric flask and funnel had earlier been washed and dried. So you make sure you use a very clean volumetric flask. Your glassware must have been washed and dried before use, which I've done to all of them, all my glassware. So I'm going to transfer it into the volumetric flask. So I'll continue rinsing. I'll rinse the salt. You keep rinsing it until the volumetric flask is half filled. is half filled, I will stop and shake the contents. Yeah, by now it is our standard flask is half filled. The next thing to do is to shake it for further dissolution of the salt. I'll shake gently out. You can shake this way. Make sure your hands is at the bottom of the flask when shaking. Shake down. It is okay. If you look at it very well, the salts have been well dissolved. You are not having particle of the salt again. It has been well dissolved. So the next thing is to add more water. You continue adding distilled water to it till it gets to a 1000 ml mark. Once it gets to 1 liter mark. So let's continue adding the distilled water. You don't use ordinary water, you use distilled water for preparation of your solution. Don't use ordinary water. At this junction, it's almost getting to the mark, so we are not going to make use of the beaker again. That's when you are now in need of our wash bottle. So you now begin to use the wash bottle to add the water, because we are not supposed to exceed the mark. You'll be watching for the meniscus of the water. At this junction, we are at the mark. The meniscus of the water is at the mark. So after that, you need to shake gently again. Gently and carefully shake it. Why are we shaking again? So as to allow homogeneity of the salt. So you shake gently, and you make sure that the cork is very well, so that the water doesn't spill out of the flask. So you shake gently. What do you mean by homogeneous solution? Homogeneous solution means the salt has been well dissolved in the water, which means that if we take sample of this solution here, the concentration of the sample of the solution here will be the same with the concentration of the solution at the top. So that's why we need to do that. So at this junction, with the last step we've taken, we have been able to prepare 0.1 molar sodium carbonate standard solution. So this standard solution we use to standardize other chemical and reagents that will be needed in the laboratory. Thank you for being. In our subsequent video, we shall be considering preparation of other chemical and reagents. Don't forget to subscribe. See you in the next video.